Well, this video is for the second half of section 2.8, which is very much like the first half, except that now we're going to be looking at functions or equations that have roots that are not whole numbers. Okay, so this will involve that synthetic division process using fractions that we talked about in section 2.7. Well, let's look at some examples here. We'll start on page 133 with problem 16. And let's see here. The polynomial is 6x cubed minus 5x squared plus 5x minus 2 equals 0. And so again, we want to start out by graphing this. 5x squared plus 5x minus 2. And let's see, I'll double check that I entered that correctly. And then we'll look at it in the standard window. And I'll show you what it looks like. Let's see here. So, see, there we go. And you can see that that root is not on a whole number. Okay, it looks like it's between 0 and 1. And we can look in the table as well and see that there aren't any whole numbers that are going to make y be 0. But you can see when x is 0, y is negative. When x is 1, y is positive. Okay, and that's what we saw on the graph. And that makes the root somewhere between 0 and 1. So we'll go ahead and find out what that root is using the root finder on the calculator. I hit second trace, choice number 2, set a left bound and a right bound. You can type in 0 for a left bound and 1 for a right bound, and that'll work very well. And it turns out that our root here is 1/2, or 0.5. Okay. And so this is what we did in section 2.5 when we were creating factors from roots, right? This says 2x equals 1 or 2x minus 1 equals 0. So there's one of our factors for this polynomial. And to find the missing factor, we want to do the synthetic division process. So let's put down the coefficients here. And so we'll use positive 1/2 to do the synthetic division. Let's see here. Negative 1. And there's our 0 remainder, which we should always get in this situation because we know that 1/2 is a root of this equation. Okay, so again, notice that we've got this common factor equal to the denominator of the fraction, and so our answer here is actually 3x squared minus 1x plus 2. So we can set this equal to 0, and then run it through the quadratic formula, and let's see what we get here. And so here, x is equal to approximately 0.16 repeating, plus or minus 0.799i. So we've got one real root and two complex roots, and so that makes all three roots. And then here's the factors for this polynomial. And if you ever want to check your answer, you can always multiply these back together and see whether or not we get that polynomial. Okay, that's problem 16. Look at a few more here. Let's see if I can get this board a little bit cleaner. There. All right. What's next? All right, we'll turn the page over to 134 and look at problem 18. 18 is fourth degree, 3x to the fourth minus 4x cubed plus 10x squared plus 12x minus 5 equals 0. Okay, so now we'll go ahead and graph this again. X cubed, 10x squared, 12x minus 5, and then I'll double check that I didn't mishit any buttons. All right, and now we'll look at the graph. Okay, so here's what the graph looks like there. And it looks like there's a root at -1, and then again a root between 0 and 1. So let's look in the table here. Second graph, we'll show you the table. And there it is. Yeah, when x is -1, y is equal to 0. Let's see, there it is right there. And then, like I said, there's a root between 0 and 1. So let's go in and find that. We hit second, trace. There's our calculate menu. We want choice number 2. Find the 0, right? Left bound. It's already on 0 as a left bound, so that's a good left bound. Hit enter. And now it wants a right bound. I'll just type in 1 because the root is clearly between 0 and 1. And then enter 2 more times. And there's our root, 0.3 repeating, which is 1/3. Okay? If you struggle with turning decimals into fractions, your calculator can do that for you. Okay? Here's the regular screen. And if I type in 0.3, I got to hit it, I don't know, 8, 10 times, something like that. And then hit the math key right here. Choice number 1 says turn that into a fraction. Okay, so there's what it looks like on the screen. Hit enter. And there's your answer, 1/3. Okay, so the calculator can turn repeating decimals into fractions if you want it to, but you've got to hit that repeating part a bunch of different times, or just a lot of times, for the calculator to get the idea that this is a repeating decimal. Okay, so now we've got the roots for our polynomial here. We've got one root at +1/3, and then the other root that we saw on the graph was at -1. Okay, so that's going to give us 2 of these factors. This one will just be x + 1, and then over here, this will be 3x - 1. And then we've got this missing factor that we're going to find by doing synthetic division. So let's pull off the coefficients here. So 3 - 4, 10, 12, -5. And again, it doesn't matter which of these we start with. I'll start with the 1/3. There's 1, -3, 9, 3, 15, 5. And there's our 0 remainder. And now we'll do this with the -1. And there's our second 0 remainder. And that confirms that these are both roots for that polynomial. Now remember, notice we've got the common factor equal to this denominator. So our answer here is actually x squared minus 2x plus 5. And so now we can set this factor equal to 0 and run it through the quadratic formula. See here. And so our complex roots are 1 plus or minus 2i. So 2 complex roots, 2 real roots, that gives us 4 total roots, and that's problem 18. Okay, so let's keep going here. All right, problem problem 20. We've got 12x to the fourth minus 53x to the third minus 31x squared minus 19x minus 5 equals 0. So, just like we always do, let's look at the graph. 53x cubed, 31x squared, 18x minus 5. Oh, and I left out an x in here. I got to go back in and enter that. Let's see here. 12x to the fourth. All right. Minus 19x minus 5. And then we'll see the graph here. And again, this one has some just kind of straight lines showing there. Well, they're sort of straight. But anyway, that's what the graph looks like. You can see there's a root out there, 1, 2, 3, looks like positive 5. And then there's another root between negative 1 and 0. So let's look in the table and see if we've got that root over at positive 5. And there it is. It's the very bottom of the table there. When x is 5, y is 0. Okay, so that's good to know. Now let's find that root between negative 1 and 0. So we hit second and then trace. And there's the calculate menu. Choice number 2 is find the 0. Left bound, I'll just type in negative 1. And then right bound, I'll type in 0. And then there's our answer right there. And that's a negative 1/3. Okay? All right. So now we've got our roots, positive 5 and negative 1/3. All right. So x equals 5. X equals negative 1/3. So this says x minus 5 is a factor. And this one says, negative 1. 3x plus 1 will be a factor. And then we're going to have this missing factor here, right? So, to find the missing factor, we're going to do our synthetic division. 12 minus 53 minus 31 minus 19 minus 5. And let's see, I'll start out with the 5 here. So that's 67. 4, 1, and there's our 0 remainder. Okay, now let's use the negative 1/3. So 12 times negative 1/3 will be negative 4. So that'll be 3 times negative 1/3 is negative 1. Another 3 gives us another negative 1. And there's our second 0 remainder. Now again, notice we've got a common factor equal to that denominator. So our answer here is 4x squared plus x plus 1. And then we set that equal to 0. And we'll run it through the quadratic formula. Let's see here. And we get x is negative 0.125 plus or minus 0.484i. So 2 complex roots, 2 real roots. We've got all 4 roots for this polynomial. Okay, let's look at one more, problem 22. Problem 22. Let's see here. 3x to the fourth, 13x cubed, minus 26x minus 40 equals 0. Okay, so let's look at the graph. All right, 3x to the fourth, 13x cubed. So note something about this polynomial is notice there's no x squared term in here. Okay, so when we do the synthetic division, we're going to have to put a 0 in place of that x squared term. Now let's see what the graph looks like. Okay, so there's the graph. Looks like there's a root out there at -4, and then also one between 1 and 2. So let's look in the table here. Hit second graph, we'll bring up that table. And yeah, there it is. When x is -4, y is equal to 0. All right, so now if we want to find that other root, right, we can hit second trace. There's our calculate menu. Choice number 2, right? Now it wants a left bound. Well, if we're looking, let's see here. If we're looking for this root right here, then 1 would be a good left bound. So let's just type in 1 and then enter. Right? Now it wants a right bound. So 2 is a good right bound there. So we can just type in 2 and enter. And now notice it says guess, right? So then we hit enter one more time. And there's our root, 1.6 repeating. That 7 is actually not correct, okay? That is a repeating 6. So that's 1 2/3. If you're not sure what that is as a fraction, right, you can come out to the regular screen and type in 1.66666, as many as you can get in there, right? And then we go into math. And then choice number 1, right? So there it is. Hit enter, and there it is, 5/3, 1 2/3. Okay, so now we've got roots at -4 and 5/3. So x equals -4 or x equals 5/3. And so this will allow us to find the factors of this polynomial. So this one is pretty straightforward. We'll have a factor of x plus 4. Here, 3x equals 5. So our other factor will be 3x minus 5. And then we've got that missing factor that we can find by doing the synthetic division. Let's see, this is a little bit sloppy here. There we go. Okay, now remember with the synthetic division, we're missing that x squared term. So we have to go 3, 13, 0, -26, -40. Otherwise, this will not work out correctly. All right, so let's start with the -4. And let's see, that'll be -12, 1, -4, 16, -10, +40. There's our 0 remainder. That's what we know we should see if we're dividing by something that we know is a root of the polynomial. Now we'll do 5/3. So 3 times 5/3 is 5. 6 times 5/3 is 10. And there's another 10. And then there's our 0 remainder. Again, notice you've got a common factor equal to that denominator. So pull out the 3, and this will be x squared plus 2x plus 2. And so now we can set that equal to 0. And run it through the quadratic formula. And here we get x is equal to -1 plus or minus I. 2 complex roots, 2 real roots, 4 total roots, and there we go. Okay, so that's it for chapter 2. I'll have a quiz set up for one of these problems, and then we'll move on and get started with chapter 3. Okay, so as always, if you have any questions, please let me know. Thanks.